Okay, so I'm going to draw the structural isomers for C4H8Cl2. And a structural isomer they have the same formulas, but just different connectivity of the atoms. So we could have just putting the chlorines on different carbon atoms as opposed to another structure. Then looking at the original structure of C4H8Cl2, it's going to be a straight chain alkene. And we can put chlorines on carbon 1. And then we have 3 hydrogens here, 2 there, 2 there. It's going to be 7. And we have 1 hydrogen here too. So this will be 1,1 dichlorobutene. I could really just move the chlorines from there. So we could start by leaving 1 and just move the other. This is going to be 1, 2. Then just moving the chlorine again. This will be 1, 3. And we could also move it once more. And this is going to give us 1, 4. If we count from this way, it's also 1, 4. They're always going to be in that orientation if we count from left to right or right to left. And we could also just move, so we could branch off of this one. Just put both chlorines on the same carbon. And going from here, we're going to leave this one here. Put that one over there. So if we try to put a chlorine on, if we kept moving the chlorine we moved before, if we put it on that carbon, it would also be that'd be 1, 3 dichlorobutane, which you already have for right there. So that's all we can do for butane, but we could also just decrease the carbon chain by 1, and now we'll have propane. And just start from the beginning, if we put both chlorines on carbon 1, and just moving and putting methyl group right here to have 4 carbons, and now just moving the 1 chlorine group. And we can just move the chlorine once more to carbon 3. So I have 1 there, 1 here, the methyl group right there. And you always want to make sure you're always counting the longest chain, because it's easy to get a duplicate of something else. Like for the when we try to put the chlorine on this carbon, it was the same as the structure. So you just want to make sure that we don't have any duplicates. We have to determine which ones are going to be chiral centers. And a chiral carbon has 4 different groups attached to it. And your best bet's looking at a tertiary carbon, which is going to have the 3 groups attached to it. Well, 4 including the hydrogen. So we can exclude the first one because we're not going to have, we have 2 of the same groups on the same carbon. That can't occur. And looking at this one, this is going to be a chiral center because we have a hydrogen, which is hidden, the chlorine. The left side's different than the right. We have an ethyl group as opposed to a CH2Cl on the right. And if we put it in the front, this will be group number 1. This side's 2 because the chlorine has a higher atomic number than the 3rd hydrogen, or than the carbon atom in CH3. The ethyl is 3, the hydrogen is 4, and therefore, if you go from 1 to 2, 2 to 3, and then 3 to 1, it's going to be counterclockwise, which is S. And that's only if the chlorine's in the front. So we have a chiral center for that one. We also have a chiral center here too. We have methyl on the left, the chlorine, the hydrogen, and the right side's different than the left. Again, if we put it in the front, this group would be 1, this is 2, 3, the hydrogen's 4, 1 to 2, 2 to 3, 3 to 1. This time it's going to be clockwise, which is R. And if we put it in the back, it'd be the opposite configuration, which would be the enantiomer. And then this one, we know we can't have any isomers. We have 2 hydrogens here, which are the same group. So nothing here, there, And this one, you had two of the same groups on, you had two chlorines in the same carbon. That wouldn't work. But these are gonna be isomers. I mean, chiral centers. So you have chlorine, a hydrogen. This will be 1. The hydrogen's 4. The CHCl has more priority over the methyl group. That'll be 2, 3, 1 to 2, 2 to 3 is going clockwise, which is R. Now looking at the other carbon, this is going to be 1. The hydrogen we know is 4. The lowest atomic number. This side's 2. This is 3. And this would also go from 1 to 2, 2 to 3, 3 to 1. That would also be R. And then we'll name them at the end. This is actually going to be a chiral center because the methyl group. Well, actually, I'm sorry. I thought we did, but this carbon has 2 of the same groups attached to it, which is the methyl group. And that can't be a chiral center because we have 2 methyls right here, 2 of the same groups. And in the last one, these 2 are identical. They're both the same CH2Cl on both sides, and therefore we're not going to have a chiral center for that carbon either. So we're going to have 3 compounds with chiral centers. And if we want to name the first one, so just redrawing it so we have some room here. We have chlorine right there. And it's on carbon 2. So if we put in the front, it'll be S, and the back will be R. It's 2S. And then 1,2-dichloro. We have a chlorine on carbon 1 and 2. And the parent name, which is butane. Next one was the one in red in the top right. And we have the chlorine on carbon 3. And also carbon 1. So we're going to go this way. And therefore it's going to be 3R. 1,3-dichloro. And butane. And you could also write the enantiomer too, which would be the opposite configuration if it were in the back in both cases. And the last one is the structure. So we have chlorines on carbons 2 and 3. And the first configuration, well, both are R. It's going to be 2R, 3R. Dichloro. And then the enantiomer would just be 2S. 3S. That'd be 3S for the enantiomer there. Then this one would just be 2R.